For as long as we've looked up at the stars, we've wondered, how does it all end? For decades, the story of the universe's ultimate fate seemed pretty much settled. It was a story of endless, accelerating expansion, the story of the cosmos stretching out into a cold, dark, and lonely eternity. We gave it a fittingly grim name, the Big Freeze. A slow, silent fade to black over trillions of years. But it turns out that story, the one we've been telling ourselves for a generation, might be wrong. What if the engine driving our universe into the infinite dark is sputtering? What if the most mysterious force in the cosmos isn't a constant, but a phantom that's slowly disappearing? Recent, groundbreaking discoveries suggest that dark energy, the very thing pushing our universe apart, is weakening. If this is true, then the end isn't what we thought. It's not a gentle fade to black. It might be a violent, spectacular, and much, much closer finale than anyone ever dared to imagine. The standard story of a runaway universe. Asterisk. Asterisk to really get why this new discovery is so earth-shattering. It all starts, as our universe did, with the Big Bang. About 13.8 billion years ago, everything, all matter, energy, and space itself erupted from a single, impossibly hot, dense point. And from that very first moment, the universe has been expanding. In the 1920s, astronomers like Edwin Hubble made a startling observation. Looking at distant galaxies, they saw that almost all of them were rushing away from us. And the farther away a galaxy it was, the faster it was going. The universe wasn't static, it was a dynamic, growing thing. This kicked off a huge debate that lasted for most of the 20th century. Will this expansion go on forever? Or will the universe's own gravity eventually stop it and pull everything back together? Think of it like throwing a ball in the air. If you throw it hard enough, it can escape Earth's gravity and fly into space forever. If you don't, gravity wins. The ball slows, stops, and comes crashing back down. For the universe, the throw was the Big Bang, and the gravity was the collective pull of all the stuff within it. The fate of everything hinged on which of these two forces was stronger. Would it be an endless expansion or an eventual collapse cosmologists called the Big Crunch? For a while, the Big Crunch seemed totally plausible. Gravity is a powerful, relentless force. It pulls galaxies into clusters and stars into galaxies. It just made sense that on the biggest scale, it would eventually win out, leading to a cosmic nab-gibber, Big Bang in reverse. Then, in 1998, everything changed. Two independent teams of astronomers were using Type Ia supernovae, incredibly bright, exploding stars that are reliably standard in brightness to measure the universe's expansion rate at different times in its history. They fully expected to find the expansion slowing down. They found the exact opposite. The expansion was speeding up. This discovery shook the foundations of cosmology. Something was out there, fighting against gravity. A mysterious, invisible energy built into the fabric of space itself was making the universe expand faster. They didn't know what it was, so they gave it a name as mysterious as its nature, dark energy. Overnight, the fate of the cosmos seemed sealed. This dark energy, which makes up a whopping 70% of the entire universe, wasn't just resisting gravity. It was completely overwhelming. The cosmological constant, an idea Albert Einstein once called his biggest blunder to keep his model of the universe static, was suddenly back in play. This constant, unchanging pressure would drive galaxies apart faster and faster. This led to the leading theory of our universe's end, the Big Freeze, or the heat death. In this scenario, the universe expands forever. Galaxies fly so far apart that the light from one can never reach another. Star formation stops as the gas clouds are stretched too thin. Old stars burn out, one by one, plunging the cosmos into total darkness. The leftover matter gets swallowed by black holes, which themselves evaporate over unimaginable timescales. In the end, all that's left is a cold, empty, silent void, where the temperature is near absolute zero and nothing ever happens again. A sad, lonely end. And for the last 25 years, that has been the accepted story of our cosmic destiny. The revelation, a fading force, asterisk. But science is a story that's always being revised, with new data challenging old ideas. And now, the most precise survey of the cosmos ever is hinting that this long-accepted story of a lonely, freezing end is wrong. The bombshell comes from an international group of over 900 scientists using the Dark Energy Spectroscopic Instrument, or DESI, from its perch at Kitt Peak National Observatory in Arizona. DESI is an engineering marvel. It's a cosmic map maker, built to create the largest, most detailed 3D map of the universe ever. Its mission is to peer deep into space and time, measuring the positions of tens of millions of galaxies to track the history of cosmic expansion with incredible precision. How does it do it? DESI uses a clever feature stamped onto the cosmos from its first moments, called baryon acoustic oscillations, or BAO. In the hot, dense, early universe, pressure waves rippled through the primordial soup of particles, like sound waves from a cosmic speaker. When the universe cooled down enough for atoms to form, these waves were frozen in place, leaving a faint pattern in how matter is spread out a preferred distance between galaxies. This pattern, the BAO, acts as a standard ruler for cosmology by measuring how big this ruler appears at different distances. And therefore at different times in cosmic history scientists can figure out how fast the universe was expanding back then. It's like looking at a yardstick far away. If it looks tiny, you can calculate its distance. DESI does this for the whole universe, looking back 11 billion years into the past. In early 2024, the DESI team shared its analysis of the first year of data, which gave the first tantalizing hints that dark energy might be changing. Then, in March 2025, they came back with an analysis of their first 3 years of data, covering nearly 15 million galaxies and quasars. The dataset was more than twice as large, and the conclusion it pointed to was even stronger. When the DESI data was combined with other cosmic observations like the afterglow of the Big Bang, known as the cosmic microwave background, and measurements from supernova and gravitational lensing, the standard model of cosmology, the one that says dark energy is constant, has a hard time explaining all the observations together. But a model where dark energy's influence changes over time specifically, where it's getting weaker, seems to fit the data much better. The evidence is piling up. We're seeing multiple, independent lines of evidence, all pointing in the same direction. The statistical significance of this is growing. In physics, the gold standard for a discovery is a 5 sigma significance, meaning there's only a 1 in 3.5 million chance the result is just a random fluke. While we're not quite there yet, the combined data now hints at an evolving dark energy with a significance as high as 4.26. That's like flipping a coin and getting heads 15 times in a row. It's incredibly unlikely to be a coincidence. As Dr. Mustafa Ishak Boshaki, a co-chair of the DESI working group, said, with a 4.2 sigma significance, we are getting to the point of no return. The evidence for evolving dark energy has become stronger. This isn't just a statistical blip anymore. This is a profound challenge to our understanding of the cosmos. If these findings hold up, it would be the biggest shift in cosmology since the discovery of cosmic acceleration itself. It would mean the recipe of the universe has an ingredient we never suspected: a dynamic, changing force that rewrites our cosmic past and, more importantly, our ultimate future. The unraveling, a new cosmic fate ***. So, what does it mean if dark energy is really fading? It means the cosmic tug-of-war between the outward push of dark energy and the inward pull of gravity is owned over. For billions of years, dark energy has been winning, stretching the fabric of space-time and pushing everything apart. But if it's losing strength, the tide of that battle could turn. Gravity, the patient, relentless force that pulls things together, could one day become the dominant force in the universe again. If this trend keeps up, the age of accelerating expansion will end. The universe's expansion would start to slow down. Over eons, it would stop completely, and then it would reverse. This is the big crunch scenario. It's the total opposite of the cold, lonely, big freeze. It's a future that is hot, dense, and spectacularly violent. Imagine running the cosmic movie in reverse. Galaxies, which have been flying apart for billions of years, would slow to a stop. Then they'd start creeping back toward each other. At first, you wouldn't notice, but as millions, then billions, of years go by, the universe would shrink. The space between galaxies would disappear. What would that look like? The night sky would become an incredibly crowded and brilliant canvas. Galaxies that had redshifted away from us, their light stretched into invisibility, would reappear. They'd blue shift as they rushed toward us, their light getting compressed to higher and higher energies. The cosmic microwave background radiation, now a frigid 2.7 Kelvin, would heat up. The entire sky would start to glow, first red, then white, then a blinding blue. As the universe kept collapsing, galactic clusters would merge. The Andromeda Galaxy wouldn't just drift into the Milky Way. It would be one of countless galaxies smashing together in a final, cosmic demolition derby. Stars would be ripped from their orbits, and stellar collisions. Now, an extremely rare event, would become common. The universe would turn into a chaotic, blazing inferno. In the final moments of the Big Crunch, the temperature would become so extreme that stars themselves would be torn apart. Planets would be vaporized. The very atoms that make up our world would be stripped of their electrons, dissolving everything into a superheated plasma. The universe would become a cauldron of elementary particles, crushed together under unimaginable pressure and heat. Ultimately, all the matter and energy in the cosmos would collapse back into an infinitely hot, infinitely dense singularity, the very state from which it all began 13.8 billion years ago. The universe would end, not with a whimper, but with a cataclysmic bang. Some theories even suggest this might not be the end, but part of a cycle. The Big Bounce hypothesis proposes that a big crunch could trigger another Big Bang, creating a new universe from the ashes of the old one. Our cosmos could be just one in an eternal cycle of expansion and collapse, death and rebirth. This is a totally different fate from the Big Freeze. It replaces an endless, cold, dark expanse with a finite, brilliant, and destructive finale. And thanks to the evidence from DESI, this once-fringe theory is now a serious contender for our universe's ultimate destiny. This is a huge shift in how we see the cosmos. The idea that the universe's end could be a fiery collapse instead of a slow freeze changes everything. But the science is still developing, and new data is coming in every year. So, I have to ask you, what do you think? Does the idea of a big crunch feel more or less awe-inspiring than a big freeze? Let me know your thoughts down in the comments. And if you want to stay on top of the discoveries that are rewriting our understanding of the universe, make sure to subscribe and hit that notification bell. A new chapter in the cosmic story. Asterisk, asterisk, the discovery that dark energy might be weakening is more than just a cool headline. It's a potential paradigm shift in our understanding of physics. The standard cosmological model, lambda c, which has been our guide for decades, is built on the idea that dark energy is constant. If it's not, the model needs a major rewrite. This could be the crack in the foundation of modern physics that opens the door to something newer, a new particle, a new force, or maybe even a hint. Einstein's theory of general relativity is Unter's final word on cosmic scales. Now, let's be clear, this case isn't closed. Scientists are cautious. The evidence is compelling, but it hasn't yet hit that definitive 5 sigma threshold for discovery, and researchers are working like crazy to rule out any hidden errors or statistical flukes. The DESI survey is only in its 4th of 5 years, and future instruments like the Euclid and Nancy Grace Roman space telescopes will provide even more precise data that could either confirm or challenge these findings. But what's certain is that we are living in a revolutionary time for cosmology. We are mapping the universe with a precision that was just science fiction a generation ago. We've created a map that stretches back 11 billion years, and on it, we've found a signpost pointing toward a very different future. The story of the cosmos is still being written. The final chapter hasn't been revealed. For years we thought the plot was heading for a quiet, somber ending. But now, it looks like the universe might have a much more dramatic, fiery, and astonishing finale planned for itself. The one thing we know for sure is that the search for the answer will continue. Out there, in the silent, sprawling, and ever-surprising dark,